Slaughter practices. Slaughter practices. First, ritual slaughter. Ritual slaughter. First, halal, jakta, kosher. Human slaughter. Stunning. Stunning. Sign of effective stunning. Immediate collapse of animal. Muscular spasm. Cessation of rhythmic breathing. Protrusion of eyeball. Extension of leg. Arching of back, neck and spine. Method of stunning. Mechanical stunning, chemical stunning, electrical stunning. Mechanical method of stunning. Physical force is used to produce unconsciousness by damaging by the brain tissue. Different way of penetrative mechanical stunning. Captive bolt pistol, pneumatic bolt stunner, water jet stunning, free bullet pistol. Point of application of mechanical stunning. Point of application of mechanical stunning. Chemical method of stunning. Chemical method of stunning. Gases such as N2O, CO2, argon, oxygen mixture are used. CO2 is suitable for peak 65 to 70% CO2 for 45 seconds. Advantage: meat is free from harmful residue and lower pH. Relaxed carcass allow easier deharing and dressing. Muscular hemorrhage is avoided due to simulated bleeding. Disadvantage: individual control of animal is not feasible. If concentration is too low, improper stunning, and if too high, animal become stuffed and bleed poorly. Electric method of stunning. Electric method of stunning. Strength of current should not be less than 250 mA and voltage not less than 75 volt. Current should be applied for a sufficient time to induce an electrolytic shock, at least for 10 seconds. Electrode should be correctly positioned. Type of electrical stunning. Low voltage stunning 7 to 80 volt for 7 to 10 seconds. High voltage stunning 300 volt for 2-3 seconds. Bleeding. Stunned animal must be positioned first for bleeding. Bleeding should be as complete as possible. Two main methods, for example, unilateral and bilateral bleeding. Carotid artery and jugular vein are cut. Species bleeding time: cattle and buffalo 6 minutes, sheep and goat 5 to 5 minutes, pig 6 minutes. Line or rail dressing system. Line or rail dressing system. Advantage: supper to operators and easy to handle. Have tools. Hygienic method as carcasses do not touch floor. Save space and reduces carcasses movement. Enhances value of skin and organs. Increases slaughter rate. Disadvantage: any dislocation on line will totally stop production. Absence of scale work may affect production. Require a large capital investment. Type of line or rail dressing system. Gravity rail system. Low slaughtering rate, example 10 to 14 beef per hour. Intermittent powered system. Faster slaughter rate and 10 to 75 beef per hour. Continuous powered system, a much higher slaughter rate, example 40 to 120 beef per hour. Can pack system, a very high rate of slaughter, example 50 to 150 beef per hour. Dressing of carcasses on slaughter floor. Dressing of carcass on slaughter floor. Meat cutting on slaughter floor and wooden slab. Splitting of carcass on floor. Rail dressing. Rail dressing hanging or carcass in chilled room, hanging of carcass in chilled room, slaughter and dressing of goat, slaughter and dressing of goat, a sticking, removal of head, removal of leg, flaying, removing of punch, carcass washing, carcass offal, removing of plugs, slaughter and dressing of pig, slaughter and dressing of pig, antemortem inspection, electrical stunning, bleeding, scalding, deharing, rinsing, evisceration, postmortem inspection, carcass washing, slaughter and dressing of cattle and buffalo, slaughter and dressing of cattle or buffalo, stunning, bleeding, dehydrating, evisceration, splitting, carcass washing, dressing percentage, dressing percentage, dressed weight, carcass weight upon live weight of the animal multiplied 100. Dressing percentage depend on species, breed, stage of maturity, degree of finish, intestinal content. Dressing percentage of different animal species dressing: buffalo cattle 43 to 54, sheep 40 to 50, goat 43 to 52, pig 70 to 75, poultry broiler 70, hens 65, duck 65. Facilities required for postmortem inspection: sufficient and well distributed light intensity must be 450 lux, clean and sharp stainless knives, provision for hot and cold water, sterilizer to sterilize knives, saw and cleavers, non-toxic and non-corrosive marking dye to put a mark on carcass and viscera, provision of detained room. General consideration of PM inspection: inspection must be done immediately after dressing. PM should be carried out in daylight. Artificial light should be avoided as far as possible. A defined sequence is to be followed for carcass and organs. Precaution must be taken in suspected cases for zoonotic disease. Identity of carcass and viscera should be maintained. Inspector should avoid unnecessary cut. Postmortem principle. Postmortem principle: visual perception. Carcass and organs examined visually for any visual abnormalities, color change, atrophy, hypertrophy, and tumor etc. Palpation. Organs palpated for any change in consistency, slimness, or cyst etc. Incision. Organ are incised if needed. Laboratory test for confirmation and support visual observation. Postmortem examination of cattle and buffalo. Postmortem examination of cattle or buffalo: head, lungs, heart, liver, stomach, and intestine, spleen, uterus, udder. General inspection of carcass. Postmortem judgment: fit for human consumption, unfit for human consumption, or total condemnation. Affected organ must be condemned while rest can be passed for human consumption. Partially condemned approved for human consumption with condition distribution restricted to limited or small amount to a consumer with instruction. Ideal handling practices to carcass and meat. Carcass must be inspected and washed properly, first with hot and cold water, then antimicrobial treatment, and again with water. Visual dirt, fat, etc. are trimmed with well sterilized steel knife. Carcass is subjected to an air blower to evaporate surface water. Carcass is passed to chilling section. Rate of cooling is important. Chilled and conditioned carcass are transported to cutting section where temperature should be below 12 degrees Celsius. Flesh and bone should be cut with sterilized knife and bone cutter. Cuts are graded and then packed accordingly. For longer storage, meat should be frozen in village condition. Ideal handling practices can be followed with some limitation. Unnecessary exposure of carcasses to mishandling, high temperature or open environment should be avoided. Personal hygiene of worker is for prime importance. Problem associated with the cooling of carcasses or meat. Problem associated with cooling of carcasses or meat. Cold shortening, thaw region etc. Handling producer to overcome this problem. Electrical stimulation for processing carcass suspension method. Cold shortening. Cold shortening Cold shortening develops when muscle is chilled below 15 degrees Celsius to 16 degrees Celsius before onset of rigor mortis. Rapid chilling of carcass result in dramatic decreases in tenderness of muscle. Beef and lamb or goat carcasses are more susceptible to the condition than pork carcasses. Low temperature stimulates massive release of calcium ion from SR without subsequent arrest of this ion. Actin and myosin filaments slide and lock together, may cause a physical shortening of 80% of original length of unrestrained muscles. Third reason, third rigor. If rate of cooling of carcasses is sufficiently high and meat freezes before onset of rigor, then on thawing muscle shortness severely up to 60% of its original length and become very tough after cooking. In thawing, there is release of large volume of drip as exudate 30% of muscle weight, and this causes less tenderness. SR become damaged during freezing and allowing large amount of calcium ion to move to myofibril during thawing. Hot processing. Hot processing of carcasses before chilling, hot burning or hot cutting. Hot processing advantage: it reduces refrigeration cost and saves energy. It requires less labor and reduced time to produce marketable meat. It increases meat yield by up to 2% as it reduces evaporative or drip loss. It gives meat a uniform color because of faster and uniform cooling is smaller part and better WHC as compared to whole carcasses. Disadvantage: it results in abnormal shape of joint. It leads to difficulty in handling and butchering of carcasses. It decreases tenderness of meat due to heat or cold shortening. Carcasses cannot be graded using normal post chilling system. Transportation of carcasses and meat. Transportation of carcasses and meat. It may be done under refrigeration by truck, rail wagon, airplane, ship beside local means. It can be done by non-refrigerated vehicle also, preferably insulated one. Point to be considered during transportation. Transportation safely plan, training of personnel, storage system, design and construction of vehicle, sanitization and maintenance of vehicle, preloading, loading in transit, unloading, refrigerated truck. Effect of transportation. Effect of transportation. Shrinkage. Loss of weight occurs as a result of evaporation from surface of carcass. A carcass may lose up to 1.5 to 2% weight during first 24 hours of transportation. This depends on wrapping of meat and humidity of chilling environment. Sweating, condensation of water vapor on carcass surface brought from cold store to room temperature. Loss of bloom caused by dehydration, oxidation, etc. It can be prevented by maintaining uniform temperature, humidity, and circulation of air in storage. Unit 9, Chilling and Freezing Storage. Unit 9, Chilling and Freezing Storage. Objective: explain chilling storage and chilling practices. Narrate efficiency of chilling and storage life in chilling store. Illustrated freezing method, rate of freezing and shelf life in frozen storage. Explain problem associated with chilling and freezing. Chilling storage of meat or carcasses. Meat must be chilled immediately after inspection and kept at a constant temperature of not more than +7 degrees Celsius. Carcass and cut and +3% offer. Ideal chilling room. Temperature should be at -1 to 3 degrees Celsius. Air speed of 0.5 to 0.75 meter per second and average about 88 to 92%. Cooling agent. Common method for carcasses is air cooling, whereas for poultry it is usage of ice water. Chilling practices. Chilling practices to attain internal temperature of 5 degrees Celsius. Goat or lamb or pork or veal carcasses require 24 to 26 hours. Beef or carcasses require 48 hour. Time can be reduced by passing high velocity air. Rapid chilling is economic, reduce shrinkage and retail better bloom, but lead to good shortening. Two chilling room may be used for big carcass. First room 50 degrees Celsius to remove body heat of carcasses, then second room 5 degrees Celsius is used as holding coolers. Following point should be considered during chilling of meat. Proper spaces between carcasses of air circulation. Hot carcasses should not be kept along with cold carcasses. Chilling room should not be overloaded. Doors of chilling room should be self-closing type. Shelf life of meat in refrigeration storage. Product storage temperature, shelf life, meat cut, minced meat, poultry. Factor that influence refrigerator storage life of meat. Species of animal that produce meat, type of product, whole carcasses, cut product, etc. Initial microbial loads, temperature and humidity condition in the storage, presence of absence of protective coverings, air circulation. Freezing and storage. Storing meat below freezing point about 1.5 degrees Celsius. Freezing is the best method for the long time storage of meat. It stops microbial growth and enzymatic action and retain most of the nutrients. Fresh meat for freezing should be wrapped properly, otherwise meat undergoes freezer burn. Quality of frozen meat depends on freezing rate, storage condition and length of storage. Freezing rate. Freezing rate. Fast freezing needs very low temperature -40 degrees Celsius. Rapid air movement or direct contact with freezing medium. Condensed gases, liquid N2, dry ice, liquid N2O used. Small ice crystals are formed throughout meat. Used drip losses during thawing less and desirable lighter cooler of meat. Shop freezing. Air is used which is poor heat transfer medium. Large intracellular ice crystals mechanically damage cellular structure, results in drip loss during thawing. Method of freezing. Still air freezing. Air is heat transfer medium. Temperature ranges between -10 degrees Celsius to -30 degrees Celsius. Plate freezing. Heat transfer medium is metal. Meat in packet or tray are placed in metal freezer plates. Temperature between -10 degrees Celsius to -30 degrees Celsius. freezing rate is faster in modified double plate system. Blast freezing, most common used for method for freezing. Rapid movement of air increases rate of heat transfer. Temperature range between -10 degrees Celsius to -40 degrees Celsius, and air velocity up to 100 meter per minute. Immersion of spray freezing, widely used for poultry carcasses. Packaged products are passed through freezing liquid, or products may be conveyed through a freezing cabinet and cold liquid is sprayed over surfaces. Most commonly used liquid is NaCl. Cryogenic freezing, nitrogen as liquid or vapor and CO2 as liquid or snow used. Generally, vapor are used in freezing chamber. Liquid can be sprayed over product while passing through a tunnel. Frozen storage life in month of different meat item: -12 degrees Celsius, -80 degrees Celsius, -24, -30 degrees Celsius. Beef, lamb, veal, pork, organ meat, poultry, minced beef and lamb, sausage. Physiochemical change during frozen storage. Drip, reddish liquid come out during thawing of frozen meat. Freezer burn, when meat surface is not wrapped properly. Progressive dehydration occurs by sublimation, result into concentration of pigment leading and discoloration. Bone darkening, commonly occur in young chicken during freezing and thawing. Muscle adjacent to bone get bloody appearance due to leaching of hemoglobin from bone marrow. Shrinkage, loss of weight due to evaporation from carcass surface during storage. It may be up to 2% in first 24 hours of storage. Sweating, condensation of water vapor on carcasses surface brought from cold store to room temperature. Loss of bloom caused by dehydration oxidation. Thank you.